Hello, everyone. I don't know whether to say good evening, good morning, good afternoon, but whenever you're watching it, it's fine. This is page 21, the Introduction to Inverses, Unit 2, Lesson 6. This is just, like I said, a basic introduction to inverses. We will get more involved with inverses and finding formulas for inverses later in the year. What they are, they're just opposites. A reflection over a line. But like I said, we will get into more detail later in the year. In exercise 1, we're looking at two linear functions, the f of x and the g of x. F of x, 3x plus 7 over 2, g of x, 2x minus 7 over 3. And what we want to do is we want to calculate f of 5 and g of 11. So f of 5, I don't know what happened there. F of 5 equals G of 11 equals. Now, we've already gone over how to substitute it in using such that or plugging it in, whatever. Whatever you're comfortable doing as long as you're getting the correct answer. So when I plug in F of 5, so that means I'm plugging it into the F of X, I get 11. When I plug 11 into G of X, I get 5. So you can see that they're opposites. And that's what's going to happen in each one of these examples. So if I look at the example here, f of 0 and f of, it's going to be g of 7 halves. So f of 0 is going to calculate out to 7 halves. G of 7 halves, so you're plugging it in here. And make sure, right now I'm showing you that you have to plug it in, and you do. Don't just assume it's going to be an inverse. So they're going to ask you, is it an inverse? Is it not an inverse? So when you plug 7 halves in, you get 0. You see how it's the opposite. The x becomes the y becomes the x. So the x becomes the y becomes the x. Next one is f of g of negative 1. So what do we have to do first? We have to do g of negative 1. So we plug g of negative 1 into the g of x, and g of negative 1 is negative 3. Then we do f of negative 3. This is a composition of functions, which we did last unit or last lesson, or 2 lessons ago. And then we have f of negative 3. You plug it in, and you get negative 1. So you see how you end up with the same value you started with? Because you're bouncing back and forth. Like here, I go from 5 to 11, and then 11 back to 5. Here I'm going negative 1 to negative 3, back to negative 1, because it's an inverse. So here we are calculating f of g of 5, so we do g of 5 first. Okay, so we have to plug in the g of 5, and we get 1. Then you put f of 1 in, and guess what it's going to be? It's going to be 5. So when you have a composition of functions and you're talking about inverses, the original input is going to be the final output. Pretty interesting. So then, without calculation, I don't know if you can see that or not. You can see it on yours, you just can't see it on mine. Without calculation, determine the value of f of g of pi. So f of g of pi is going to be pi, because they are inverses. And again, you'd have to prove it first before you can say that. Now, the two functions seen in exercise 1 are inverses because they literally undo each other. The general idea of inverses, f of x, g of x, is shown below in the mapping diagram. So what it's showing here is that the domain of f, so the x values of f, are the y values of f. So what will happen then, those y values become x values of the g, and the y values were the original x values. So they are flip-flopping. They're like opposites. So taking this context, and you can pause this anytime you want if I go too fast. I know some of you are saying that it's pretty quick, but you can pause it, kind of reflect on what I said, rewind it, play it again as we move on to exercise 2. So if the point negative 3, 5 lies on the graph of y equals f of x, then which of the following points must lie on the graph of the inverse? So what we did with the inverse, if you look up above, we had 5, 11 became 11, 5. 0, 7 halves became 7 halves, 0. So you see how we just flipped the x and the y? So now, if I have negative 3, 5, what do? I flip it, and it just becomes 5, negative 3. You just switch the order. And that's what happens as long as you know it is an inverse. All right, I had some notes from last year on I had to get rid of. The inverse notation. If the function y equals f of x has its inverse, it's also a function, we represent it as f inverse. So f to the negative 1 of x means the inverse. So if you have f of x, that's a function of x. F negative 1 of x, that's the inverse of x. So we have a linear function shown graph below. Use its graph to answer the following questions. Now, what's very helpful is to identify the coordinates. So we're going to start from left to right. So we're going to start with this one and just name each one. So the original coordinates, starting from left to right, are negative 6, and then we have negative 3, negative 4. Then we have 0, negative 2, 3, 0, and then 6, 2. Those are all the original coordinates. So f of negative 6 has a value of negative 6. F of negative 3 has a value of negative 4. Okay, your input-output that we looked at in a previous lesson. So if I want to evaluate the inverse, so if I'm looking at the inverse, f inverse of 2, that means that I'm looking at the opposite. So 2 would be my y, and therefore my f inverse of 2 will be 6, because it's the opposite of the original. The original was 6, 2, so I'm doing the inverse of 2, which gives me the x value. Now, f of negative 4, the f inverse of negative 4, here's my negative 4, and therefore that would be negative 3. Okay, and then it says determine the y-intercept of f inverse of x. So that y-intercept is going to be, the y becomes the x, so it's 0, 3. Oh, I think they want the coordinate. 0, 3. Okay, and then they say on the same set of axes, draw the graph of the inverse. So when you draw the graph of the inverse, what happens, some of them land right on top of each other. So this first one lands right on top. Negative 6, negative 6. So if I flip it, it's the same thing. If you flip this one, and I'll put it in a different color, it becomes negative 4, negative 3. So that's what we need to graph. Negative 4, negative 3. And then this becomes negative 2, 0. And you can list them. These are the inverses. This one becomes 0, 3. And then the final one becomes 2, 6. Just like that. Okay, and then the line is there. Okay, see that is the graph of the inverse. Now what we're going to get into later on in the year is that the graph of the inverse is a reflection over the line y equals x. So the line y equals x is right here. That's the line y equals x. And as we investigate this more, we are going to put this in your graph, and you're going to see that it is reflected over that line. Okay, and then you have an inverse. And exercise 4, I think this is the last one. Table of values for the simple quadratic function. There it is. Graph the inverse by switching the ordered pairs. So we switch the ordered pairs. So then it's 4, negative 2. 1, negative 1, 0, 0, 1, 1, 4, 2. Y's become x's, x's become y's. So what do we have here? We have 4, it says graph it right, table of values, along with its graph. And what do you notice about the graph of the function inverse? So we're going to put it on to take a look at it. So 1, 2, 3, 4, negative 2, 1, negative 1, 0, 0, 1, 1, and then 4, 2. Okay, so it looks like this. Okay, now what do you notice about the graph of this function's inverse? Now, the one thing is the original is a function. The inverse vertical line test is not a function. So what do you notice about the graph of the function's inverse? That it is not a function because it fails the vertical line test. I'm not going to write all that out because it's all scribbly with this pen I have. So the existence of inverse functions, a function will have an inverse that is also a function if and only if it is 1-to-1. So a quick way to tell if a function inverse is also a function is to apply the horizontal line test. So if we went to the original function, f of x equals x squared, and we did the horizontal line test, it fails the horizontal line test. Therefore, the inverse is not going to be a function. And we will investigate that later on in the year as well. Okay? So it might be a little tricky, maybe a little confusing. We can discuss it, in class, the questions, and straighten it all out to make sure that we have a better understanding if we are confused. Okay, well, we will see you in class.